Hey, it's Dr. A. I got a really great question after a couple of the digestive videos went up, and I got a lot of them. One, though, was people talk about macros with respect to your diet, and what does a macro mean, and how does that relate to the food I eat, and also the nutrition that I get. So this is a really good question. A lot of people, especially since certain types of diet plans became more popular, like keto and other stuff, people talk about, well, your macros have to be here in this percentage or whatever. What they're really talking about is what I mentioned in the previous video was macronutrients are essentially what you see. So this would be large scale things like fats, carbohydrates, and proteins. How does that relate to your nutrition? Well, when you eat a fat, carbohydrate, protein, or usually some mixture of those, you're getting those macronutrients in certain percentages. But then your body goes through all this digestive stuff that we've been talking about to break them down into micronutrients. So micronutrients include some things that are included but kind of peripheral to fat, carbohydrate, and protein, such as vitamins and minerals and polyphenols, bioflavonoids, all of those good things. So I just want to focus on the big macros today. And so fat, carbohydrate, and protein, what do they break down to? Well, as we talked about, you got all this machinery to break down your food. It starts with you seeing and smelling the food, and then your digestive system gets going. And remember what we said before is if your digestive system neurologically is in a position to digest better, so you're in parasympathetic mode, it's more resting, digesting, etc. So you're not running around, you're not driving and eating, you're not, on a Zoom call eating, whatever. You're going to have more capacity to digest because that's the part of your nervous system that lets everything operate. But then other things come into play, such as putting the food in your mouth. That starts the digestive enzymes actually in the mouth and triggering downstream chewing. Obviously, the better you chew the food, the easier it is for the rest to break down. Then when it gets down to your stomach has this acidic phase where it churns around the food with acid, and that helps to open things up. And then we talked about the other phases. But I was trying to think of how to describe without using a video or something like that, getting from a macro down to micronutrients. Well, if you think about it, let's say you have carbohydrates. So those are things that are going to break down into polysaccharides and then single sugars usually. Sugars we talked about with respect to blood sugar and all that stuff. So carbohydrates are what give us sugar. They also give us indigestible carbohydrate, things like fiber, etc. But I thought, well, the best way, because I have grandchildren, to illustrate this without a video would be Legos. Okay, so just be kind to my Lego work here. But if you take, this is a carbohydrate, okay? This is a complex carbohydrate, and each one of these little Legos that are different colored would be a single sugar, and this little one here would be a branch point, just because I had to throw one of those in. Now, what's all the green stuff in the back? Just ignore that. But a complex carbohydrate is going to have a lot of sugars, and they're going to be strung together and stuck together. So when you chew it, like say you potato or bread or something like that, you're going to start to break it down. It's going to mix with the enzymes in your mouth, and then it's going to hit the acids in the stomach, and then the enzymes in the duodenum. And what's going to happen is that slowly these things are going to break down. Now, you might get it into a certain phase of digestion, and you might have removed a number of these, and you might have then what's left over, which would be a polysaccharide. These usually are not supposed to digest. They can get in, but usually they don't. And what your body is going to try and do then with some specialized enzymes is cut these links apart here. So then when it gets down to your small intestine, you're going to have these individual sugars, and those are going to be pumped into the blood. And that helps to become the blood sugar. Now, there are different types of individual sugars. That's basically the idea. So your carbohydrate macro starts out with that big, long chain, and polysaccharides come in lots of different shapes. Some of them are spiral, some of them are branched, and all that stuff. But that's the bottom line, is that you're going to try and break them down into single sugars so they can get absorbed. If they don't get broken down all the way, what happens? They often get downstream in your digestive tract, and the bacteria that are in there start to feed on the polysaccharides, and you'll get gas and bloating and even pain and diarrhea from that. Now, what about fat? So fat's fairly obvious. You're going to find it, most people think of it in, either oils or meat or whatever. There are fats in plants as well. Fats come in these long strings called fatty acids. Now, if this was real and I had more time and more Legos, this would be a lot longer because there'd be a lot more branch points. But basically, it looks kind of like a zigzag. And the idea with a fatty acid is that this is going to be in, let's say you put oil on your food, or you ate meat or whatever, or fats in a plant or something. These are going to be a lot of fatty acids that are going to be put together in whatever form that food was when it started. You're going to eat it, chew it up. The heat in your stomach is going to start to adjust it, and then it's going to get down, and you are going to have this long string of fatty acid that is going to get separated from all of its cousins, and it's going to get taken by the bile and made into a special little package. That package then is going to be put into certain cells in your small intestine. It's going to be repackaged into something that's a lot like it's a cousin of the cholesterol molecule. And then that's actually going to be absorbed with a whole bunch of these floating around into your lymphatic system, and then eventually back to your blood. Now, what happens then is the fate of fats is a little bit different in that if you're going to go and take this and your liver takes it, your liver can take this all apart and put it into a free fatty acid sort of savings account. And they do that, liver does that. Liver can reassemble it, put it into cholesterol and send it out for your cells. But the other thing that can happen is your cells might see something like this, fatty acid that gets delivered to it, and need it for energy. What's going to happen then? Well, you can't burn this whole thing. This is a very long structure. And if you look at most of what is burned in the mitochondria, it's usually 2 units at a time. So when the fat gets to your mitochondria, there's actually an enzymatic system that cleaves it off, and it's going to take a chunk at a time. So usually 2 at a time, called beta oxidation, and that's going to turn into energy. So if you don't wind up using this whole thing for some other fat process, you can make a lot of energy out of it too. Then the final component is proteins. So proteins, we often think of protein powder or meat, or you can get protein from all sorts of things. There's a lot of vegetable proteins and all of that. But wherever you get your protein, that's one of your big 3 macros. And so proteins break down into a couple of layers. Now, proteins are more complicated in their structure than either carbohydrate or fat for the most part, because there's different levels. Most of the proteins that you're going to eat are going to be either what they call tertiary or quaternary proteins. So they're very complexly folded, and they're made up of peptides. Now, people nowadays talk about peptide therapies. You see those used medically. It's been used for a long time, but they're more available and cool now. Well, those are basically little chunks of amino acid sequences that are from a protein. They're usually synthesized if they're a peptide medical therapy. But the idea is that the peptide is going to be one of the base units of the protein. Now, the more peptide strings that you have together, the more complex the protein, the higher order it is. So if you look at something like insulin, it's got all sorts of peptides in it. If you look at hemoglobin, it has massive amounts of peptides that are folded, and then come together in this giant quaternary structure. Well, when you eat those things, whether it's from plant or animal, the proteins are going to go in. The first thing that happens after chewing, of course, and a little bit of the enzymes from the mouth is they're going to go into the stomach, and a lot of the folding has to be opened up. Well, the stomach acid is able to open the weaker bonds on the outside of the folding. And so if you look at, proteins like a really complex 3D structure, and I made a very simple one here, but you've got a lot of folding of different peptide strengths, and it could look really hairy if I did a real Lego version of it. But the bottom line is that we want to break this down because, again, most peptides don't fully absorb through the GI tract. There is a way for that to happen, we now know. But what you want nutritionally out of your macro for your protein is not the peptides, but you want the amino acids. So the first thing is the stomach has to open the weak bonds up and make these long strings open. And then the lower you go on the order towards amino acids, the tighter the bond is. So you need more and more energy to break it down. Now you have these enzymes called peptidases, named because they break peptides, in your GI tract, and they help with this. So the goal is that you start to disassemble this, and you're breaking it down, and you're taking these all off so that these can all go and be broken down. And then you're going to wind up with a polypeptide like this, and it's going to get to these intestinal peptidases, and the goal then is to break off each individual amino acid, and so the amino acids can get absorbed into your bloodstream. Now you can actually absorb a few amino acids at a time into your GI tract cells, and then you have peptidases inside the cell that will shoot the amino acids in. But that's what you're going for. Out of this giant structure, you're trying to get one amino acid at a time off of its binding site to get in. So your macro of protein becomes peptides, and then the peptides become amino acids so that you can use those, and they have all sorts of good fates inside of your body, most of which are for making a lot of things. They're not used so much for energy. They can be, but they're mostly used for making and repairing in your immune system, all sorts of really good things. But that hopefully answers the question about what are macros. So macros are literally the macroscopic part of your diet, the fat, the carbohydrate, the proteins, and all their associated nutrients. And you break them down to micronutrients. And so your ultimate goal with sugars, with carbohydrate, is single sugars, monosaccharides. Your ultimate goal with fats are free fatty acids that can be broken down further. And your ultimate goal with proteins are going to be first peptides and then amino acids. All right. I'll link the other ones down below. Please like, share, subscribe, all those good things. If you like this, share this with friends. We're getting a lot of good feedback, and comment if you want to. Thank you very much.